Scaffa is here. He's the chief guy with Zweji, and he's just told me that the millivolt range for oxygen is 700, and he's done that, and now he's going to
change the range of the instrument to the 10, or I should say 100 nanoamp range. Right now it is 1 microamp range.
okay,
Right above
so,
my finger.
so on a tenth of that, so
Right.
100 nanoamps.
Right, and I'm going to go to the menu, which you can access by first hitting the X button,
Mm-hmm.
then hitting the checkmark button.
Mm-hmm.
Now you have different options which you can scroll for temperature. I'm going to check current, highlight that, and then there's a sub-menu, waveform. I'm going to go over to range. I'm going to check that. And here, now it's 1 microamp highlighted. I'm going to move it over to 100
Got it.
and check that.
So you don't adjust that with the screwdriver.
No, that's
It's
a
the-
sub-menu that's
Okay,
accessible.
cool. Okay.
And so now, I get out of
And
here.
for NO, what would I set it at?
For NO, depending on the type of sensor and temperature you're working at, it would normally at room temperature be in the 10 nanoamp range.
Okay.
If
Versus 100 for oxygen.
right, but if you're going to work at an elevated temperature, you might have to move to a 100 nanoamp range because
Okay.
the baseline current will increase with temperature.
And then the millivolt range for NO is 800 and...
Well, you want to set as close as you can to what it should be. So for nitric oxide, it should be 850.
Okay. And for hydrogen sulfide?
Hydrogen sulfide it would be 150
Okay.
millivolts. And so oxygen is 700. Hydrogen peroxide is 450.
Okay, cool.
So again, that will be described in detail in the manual.
Okay.
Right now, one of the other things that are here, this is the number of samples per second it's currently acquiring, which is 2. I want to change that based on the LabTrax data acquisition, so I want to make that a little bit more frequent. So I'm going to go over here. If I go to options, I'm going to check that, and I'm going to scroll all the way over to sample rate. Highlight that. I want to set this a little higher for 8 samples.
8 samples per second. Okay.
So we get a little bit more data. And I'll close out. So now we've changed it to 8 samples per second here. And we're operating again in the 100 nanoamp range.
Okay.
And as you can see with the LabTrax system, our value on the Apollo 1000 is about 19.5 nanoamps.
Okay.
Close to 20.
Uh-huh.
And here, if you look at the channel, we are also close to 20.
Okay, got it.
Just a little bit, which is this baseline here. And if I, now we're looking at roughly a minute and a half worth of data. So you see the data being plotted from the acquisition of the unit.
And there is an electrode in place.
Yes, this is the oxygen sensor, which is
Okay.
connected from the input of the Apollo all the way to our sample here. This is sitting in PBS buffer,
Okay.
and this is our 2 millimeter oxygen electrode, which is the green cable.
Which is just the size I want to put in the apparatus that I'm building. Okay. So I'm
So-
going to stop this now.
We can stop, yeah.